Section 3.3 Algebra is explaining the complex numbers. Remember, when you have a quadratic equation, ax squared plus bx plus c, we used to get the solution for this equation in this form. Minus b plus minus radical b squared minus 4ac over 2a. In the case that this, whatever is under the radical, is negative. So b squared, if I have b squared minus 4ac is less than 0. It's a negative number. This radical will have no solution, so this quadratic equation will have no solution. For the mathematicians, they need to find a solution of this equation. So they invented something called imaginary number. Imaginary number I, it is equal to radical minus 1. So if you have radical minus 1, you're noting it by an imaginary letter I. So in this case, the solution of this equation, it will be a complex number. It will have a solution as a complex number. So for example, if you have a solution as radical minus 4, you can write it as radical 4, radical minus 1. So you remove the radical minus 1 and you put it as I, and radical 4 is 2. So the solution of this equation, instead of radical minus 4, it will be 2i. And I know that I is an imaginary number that is equal to radical minus 1. So any complex number, C, it is denoted as a plus bi, where a is the real part of this number and b is the imaginary part of the complex number. So if you have any solution, if a is 0, so your solution is purely imaginary. If b is 0, your solution is a real number. So this is why they are saying that the set of real numbers is a subset or a part of the complex numbers, because if your imaginary part is 0, your answer will be a real number. This learning point, the equality in C, in complex number. Any two complex numbers, they are called equal if the real part is equal to the real part and the imaginary part is equal to the imaginary part. So for example, this is two complex numbers. So here I say this is two are equal if this real part is equal to this real part and this imaginary part is equal to this imaginary part. And therefore he is solving to get the x and the y. Adding and subtracting complex numbers, you are adding the real and the real, and you're adding the imaginary with the imaginary. So if you have a plus bi and c plus di, when you add, you will add a to the c, both are real, and you will add b to the d, both are real. Or you also subtract ac and bd. Multiplication of a complex number is very simple. If you're multiplying, for example, 3 times a plus bi, you multiply the 3 times a and the 3 times the bi. And if you are multiplying two complex numbers, for example, a plus bi times c plus di, you will multiply the a times c and a times di plus bi times c and bi times di. So when bi times di, it will give you I square, and I square is equal to minus 1. So the real part of multiplication of two complex numbers, it will be ac minus bd, and the imaginary part will be ad plus cb times the I. So learning point 2, solving a quadratic equation with complex roots. Come on, for any quadratic equation, you can get the solution using this formula. We took it before. Minus b plus minus radical b squared minus 4ac over 2a. So for example, if he's asking you to solve this equation, you will just substitute in here and you'll get that the radical is minus 36. So you will take minus 1 outside, so it will be, and you will denote it as I. So your equation will have two roots, minus 2 plus minus I radical 36, which is 6 over 4. So this will have 1 over 2 plus minus 3 over 2i. So you can get the solution of any equation using the imaginary number I. And this is just another way of solution, factoring over the set of complex number. For example, if you have an equation 10x squared plus 1000 and he wants to factorize this. So you'll take the 10 outside, x squared plus 100. Now x squared plus 100 has no solution, but if you're using the imaginary I, so you can find the two roots of it. So this plus 100, it will be minus 100 squared, and then it's like x squared minus 9, for example. It is x plus 3 and times x minus 3. So this is the same thing. The 10 is here, the same. And you have x minus 10i and x plus 10i. So this is the factorizing. Here, for example, the same thing. He wants to factor this. You'll take the 5 outside. So we'll have x squared plus 25. So for example, here it will be x squared plus 25. And here you have the 5 outside. So this will be 5x squared minus 25i squared. And then you will factorize it as x minus 5i and x plus 5i. So this is factorizing. Here it's a x squared plus 4x plus 5. So you have x squared plus 4x. He removed the 5 and put it plus 4 and then plus 1, because x squared plus 5, you don't have a number like, for example, 1 times 5 and 1 plus 5, it will not give you 4. So he split it to x squared plus 4x plus 4, and 2 times 2 is 4, and 2 plus 2 is 4. So here you have x plus 2 all square plus 1. This is the remaining 1. So again, this is a number, this is like x squared itself, and this is plus a number. So you cannot factorize this, you have to make it minus I squared. So you have x squared, x plus 2 minus I, and x plus 2 plus I. So this is factorizing of this equation. I will do this one also as an example. So x squared plus 8x plus 25. I need two numbers. When you add them, gives you 8. It is like 4 and 4. 4 plus 4 is 8, and 4 times 4 is 16. So I need x squared plus 8x plus 16 plus 25 minus 16 plus 9. And this one, it is x plus 4 all squared. 4 times 4 is 16. 4 plus 4 is 8 plus 9. So this one, to factorize it, I need this to be minus. So x plus 4 square minus 9i. I squared طبعا. Minus 9i squared. So this one as it is, x plus 1 and then x plus 1 minus 3i plus 3i. So this is factorizing that equation. Now I will solve the course practice 3.3. What are the roots of x squared minus 4x plus 5? So this one, you know that it's an imaginary. So I will just substitute into the equation minus b. So minus b, it will be 4 plus minus radical b squared. 4 times 4 is 16 minus 4 times 1 times 5. 4 times 5 is 20, so minus 20 over 2a, which is 2. So this is equal to 4 plus minus radical 16 minus 20 is minus 4 over 2. So this is equal to 4 plus minus radical 4, it's radical minus 1 and radical 4. So radical 4 is 2 and radical minus 1 is I. So I have, the 2 will be 1, this will be 2, this will be 1. So I have 2 plus I and 2 minus I, which is these two. 2 minus I and 2 plus I, or I plus 2, it's the same. Express the given complex number in a form of a plus bi, where I is equal to radical minus 1. So I have I to the power of 12 minus I to the power of 7. Type I to the power of 12, it is I squared to the power of 6. 6 times 2 is 12 minus I squared to the power of 3. 3 times 2 is 6 and I. Okay, so this is I to the power of 6 times I, which is I to the power of 7. So this is minus 1 to the power of 6, it will equal to 1. And this is minus 1 to the power of 3, it is equal to minus 1. So minus, this is the minus. Minus 1 to the power of 3 is minus 1. So times minus 1. I. So the minus will go with the minus. So I have 1 plus I. Question 3. Which of the following factors 45x squared plus 20 over the set of complex number? And then part B, he's like factorizing it. So I will use the factorization to know which one. So I have 45x squared plus 20. I will take 5 as a common number. So I have 9x squared plus 4. Okay, so this one I will keep the 5 outside. Here 9x squared plus, I need here to have minus 4i. So this is, I have the 5 here as it is. 9x squared is 3x and 3x. Minus 4i is minus 2i plus 2i. So this is the 2 factorization of this. Okay, so here I think this is what he wants. So you have 5 and then 3x plus 2i, 3x minus 2i. You can put minus 2 here and plus 2 here, or keep it the same. So what are the factors of this equation? 5 is a real number, so 3x minus 2i or 3x plus 2i, which is these two solutions, 3x plus 2i, 3x minus 2i. So here I use the factorization method. Question 4, he gives you two complex numbers z and w, and he wants 5z minus 3w. So I will multiply 5 times this. So 5 times minus 4 is minus 20, plus 5 times I, so 5i, minus, I will multiply minus 3 times this. So minus 3 times 2 is minus 6. Minus 3 times 6 is minus, 3 times 6 is 18i. And then simplify, minus 20 minus 6, so this is minus 26, plus 5i minus 18i, so this is minus 13i. B, he wants 4z plus 7w, so I'll multiply 4 times this, so minus 4 times 4 is 16, plus 4i, then plus 7 times this, so plus 7 times 2 is 14, 7 times 6 is 42i. So here you have minus 16 plus 14, so you have minus 2, and plus 4 plus 42, so it will be plus 46i. So you have minus 2 plus 46i. Question 5, you have two complex numbers and he wants z plus w. So z plus w, you will add the real and real, imaginary and imaginary. So minus 4 plus 5 is 1, plus 9 minus 6 is plus 3, so 3. Z minus w, minus 4 minus 5 is minus 9, so this is minus 9. 9i minus 6i, so it will be 9i plus 6i, so it will be plus 15i. Question 6, find the value of x and y for these two imaginary numbers to equal each other. We said for the imaginary number to equal each other, real part must equal to the real part. So 7x equal to minus 21, so x is equal to minus 3. And the imaginary part, which is minus 8y, need to equal this imaginary part, which is 4x minus 5y. So here 5y will go to the other side plus, so you have minus 3y equal to 4x. 4 times minus 3 is minus 12. Minus will cancel the minus, divided by 3. So y is equal to 4. So your x need to equal minus 3 and the y is equal to 4. Question 7, two complex numbers and he wants z times w. So 5 times 2 is 10. 5 times minus I is minus 5i. 4i minus 2 is 8i. 4 times, this is positive negative, so negative. 4 times 4i times I is minus 4i square. I square is equal to minus 1, so this term is equal to 4 and positive because this I square is minus 1 times minus, so it will be positive 1. So 10 plus 4 you have 14, minus 5i plus 8i, it will be equal to plus 3i. So 14 plus 3i, this is in simplest form. Question 8, find the roots of this equation. X squared plus 6x plus 25. Simply I will use this formula. So minus b means minus 6, plus minus radical. B squared 6 is 36, minus 4 times a times c. 4 times 1 is 4. 4 times 25 is 100, so minus 100 over 2a, which is 2. So I have minus 6 plus minus radical minus 64 over 2. Minus 64 is 64 and radical minus 1. So this is minus 6 plus minus radical 64 is 8. Radical minus 1 is I over 2. Simplify. Divide by 2 is 1. Here minus 3 and here will be 4. So minus 3 plus minus 4i. So one solution is minus 3 plus 4i and minus 3 minus 4i. Question 9, you want to factorize this equation x squared plus 10x plus 41. I need two numbers, the same numbers. When I add them, I get 10, so 5 plus 5. So I have x squared plus 10x. 5 times 5 is 25, so plus 25. 41 minus 25, it will be plus 16. I will take this separately. So this is x plus 5 square. And this is plus 16. This number squared and number square, I need here negative sign. So x plus 5 square minus 16i square. Until now I didn't do anything. So this square, square and negative. So this is x plus 5 minus 4i and this same x plus 5 plus 4i. Minus 4i plus 4i is negative 16i square. So here I factorized it. So here you have x plus 5 plus 4i and x plus 5 minus 4i. This is positive, so here you have to put minus 4i. Or here minus 4 and here 4, it's the same. Question 10, two complex numbers. He wants 2z plus 4w. So 2 times this, 2 times minus 4 is minus 8, 2 times 9 is 18i, plus 4w, so plus 4, 5 is 20. 4 times 6 is 24i. Simplify. Minus 8 plus 20 is plus 12. 24 minus 18 is minus 6i. So 12 minus 6i. The second one, he wants 5z minus w. So 5 times minus 4 is minus 20. 5 times 9 is plus 45i. Minus w, so minus 5 plus 6i. Minus 20 minus 5, so minus 25. 45 plus 6, so plus 51i. Last question, he wants to multiply this. So minus 3 times 5 is minus 15. Minus 3 times minus I is plus 27i. 2i times 5 is plus 10i. 2i times minus 9, it's minus 2 times 9 is 18i square. 18i square is, this is what minus 1 times minus 1, so it will be positive 18. Minus 15, so it's 3. 27 plus 10, so plus 37i. So in simplest form, it is 3 plus 37i.